Hello everyone, welcome to my class. I am Dr. Vijayketan Sahu, Department of Chemistry, School of Science, Gitam deemed to be University, Hyderabad campus. Today's topic is corrosion and its control. So before going into details on corrosion and its control, let us look into some examples in and around us, in our society. Right? So let us see, for example, sometimes we come across in the newspaper and the news channel, somewhere in some place some bridge has been collapsed, or some building has been collapsed, or some other big structures has been collapsed, and also we come across like some industrial failures. There could be many reasons for this, maybe collapse of the bridge, or maybe structure, or maybe the industry failure, but one of the reason is corrosion of the metal used therein. In addition to this, also we can come across some more examples in our day-to-day life. If we see the examples in and around our home, also we can see the example of a corrosion. Example, if you throw a nail to the outside, if it is exposed for at least nearly about 1 month, you see a compound is formed over the surface. That is reddish brown. That means the metal has undergone corrosion. And also when we bring any metal for the different purpose, maybe like for the making door, or maybe windows, or maybe grill, what we do, we coat the metal by a paint. What is the reason for coating? Is it for good looking? It could be one of the reason, but the main reason is to prevent the metal from corrosion. Let me show you one example here. So here, if you see, this is a pure nail, iron nail. It's not corroded. Now, if I show the another one, this is a corroded iron nail. Another one is, if I show another one here, see. It is not pure one. It is not corroded one. Pure one, but what happens here? It is coated by some other metal. That means this nail is protected. Right? Iron metal is coated by some other metal to prevent it from corrosion. If I hold it at a time, all the three, have a look into this. These three examples. This is pure iron nail. This is the corroded one. This is the protected one. Got it? So overall idea what the corrosion is and how it is being protected. Now after this I will show the collapsing of a bridge. Have a look into that video, collapsing of a bridge, that happens in Taiwan in 2019. Let us discuss on corrosion and its control. So this is the collapsing of a Gokhel bridge at Andheri, Mumbai on July 3rd, 2018. Another example, the Nanfang bridge collapsed in Taiwan on 1st October 2019. Some other examples like the corrosion in marine system. This is the corrosion of a ship. This is the corrosion of a submarine. These are some of the examples of corrosion in transport system and some industrial equipments. Have a look into this slide. What we can see in this slide? What change is there in the materials? If you look into here, this is pure iron nail. This is the corroded one. This is glass made from copper. This is undergoes corrosion, inner side green color. Statue of Liberty. This is the original color. This is the present color. We see there is a change in the color. What change color? Let us see. So here iron silver gray has gone to reddish brown, copper reddish brown to green, and the Statue of Liberty copper color to green color. Now the question is, why the color has been changed in each case? So here, also here, also here. What is the reason for color change? The reason is the metal react with its atmosphere called as corrosion medium, and forms a compound over its surface and called as a corrosion product. So this surface compound is the corrosion product and it looks as colored. Now the question is why the metal reacts and give this corrosion product. Let us go into the next slide. Now here how we get the pure metal. Have a look into here. So here mineral or ore, we mine it from the underground. Process is extraction process. We get the metal. Then pure metal undergoes corrosion, give the corrosion product. Now, as I mentioned, metal comes from the ore. Ore is nothing but a compound of the pure metal. Now, by using energy, we get pure metal from the ore. That's why metal is in the higher energetic state compared to ore. Why? Because we mine it from the underground by using energy. All the energy is being stored here. That's why this is a highly energetic state. And when it is exposed to the atmosphere, it undergoes corrosion and gives rise to corrosion products. That is oxides and sulfides, maybe carbonates also. So now the metal goes into the compound state that we call as corrosion product. And this process is a natural process, spontaneous process. Spontaneous means it happens or it takes place on its own. As I mentioned here, in this process, natural process, spontaneous process, energy is released. Energy released means this corrosion product has less energy as compared to metal. That means it is less energy, this is more energy. And the natural principle is the matter is more stable with less energy. That's why every matter wants stability. As if we compare now the pure metal and its corroded state. Out of these two, the metal is a high energy state as compared to corroded state. That's why metal react with its surrounding to go to the stable state, that is the corroded state. And gradually it converts into ore. Again we mine it and we get the pure metal. What is corrosion then? How we can define it? It is unwanted destruction of a metal due to its chemical or electrochemical reaction with its surrounding or environment, leading to reduction in the thickness of the metal and loss of some metallic properties like malleability, ductility, electrical conductivity, and so on. Some examples of a corrosion. Example is rusting of iron. Iron react with moist air, oxygen and water, give rise to ferric hydroxide, which is nothing but a rust compound over the pure metal. Here this glass is made from copper, but surface looks like a green. Why? Copper react with the carbon dioxide in its surrounding and give rise to copper carbonate, which makes the surface green in color. This is the corrosion product. This is made spoon made from silver, but this is got a tarnished. What is this tarnished product? That is nothing but your silver sulfide. Silver react with the sulfur. Where from sulfur comes? It comes from hydrogen sulfide gas in the atmosphere and give rise to this. This is silver sulfide is nothing but the corrosion product over the tarnished spoon. Now thermodynamics and kinetics of a corrosion. What thermodynamics and kinetics gives about corrosion? Not only corrosion, thermodynamics and kinetics give information about any reaction. Corrosion is also a reaction. Have a look into these three reactions. Magnesium, copper and gold, all they react with water and oxygen, give rise to their hydroxides. Now, if a question comes, do all these metals react with the surrounding of the environment, maybe like water and oxygen, and give these products? Who can answer this? How will know whether the reaction is possible or no? That's called as feasibility. Whether a reaction is possible or no. If the reaction takes place, whether it's a slow reaction or fast reaction, that's called as a rate of reaction. That's why we come across two questions. One is whether a reaction is possible or no, that's called as feasibility, and another is fast of reaction called as rate of reaction. This feasibility of a reaction can be answered by thermodynamics. That is, the thermodynamic parameter gives free energy change, that is delta G. If the delta G of a reaction is negative, the reaction is possible. If it is positive, reaction is not possible. Have a look into here now. Now for these three reactions, these are the change in free energy values: negative, negative, positive. That means for these two reactions, del G is negative. That indicates or reflects that these two reactions are possible. As it is positive, this reaction is not possible. That means this product is not formed. Gold does not react with water and oxygen. That's why gold is a noble metal. It does not undergo corrosion. And you see, we use gold in our day-to-day life as ornamental metal, and we have seen there is no corrosion. This is the reason why. So this thermodynamic parameter defines the feasibility. And fast of reaction or slowness of reaction, that's called rate of reaction, explained by kinetics. Types of corrosion. Primarily, there are two types. One is dry or chemical corrosion, another is wet or electrochemical corrosion. What is dry or chemical corrosion? As the name dry means it happens in absence of water or aqueous medium. Why chemical? Means a chemical reaction takes place. That's why dry corrosion or chemical corrosion. So what it is exactly? Due to direct chemical action of atmospheric gases on metal surface. What is the meaning? When a metal directly reacts with the atmospheric gases in its surrounding, the corrosion is called as a dry corrosion. What are the gases? These are the oxygen, sulfur dioxide, carbon dioxide, hydrogen sulfide, chlorine, etc. Now, based on the nature of the gas, the corrosion product will be different. If oxygen, oxide. If like SO2 or H2S, it is sulfide. If chlorine gas, it is chloride. If carbon dioxide, it is carbon. So these are the different corrosion products over the surface of the metal. Example here: metal exposed to the atmospheric gases. Now gas react with the metal. This little bit corrosion product is formed. More exposed time, more corrosion product. Still more exposed time, more corrosion product. These corrosion products could be any of these based on the nature of the gas. One example is here. Already I have told, tarnishing of a silver. Now, what is wet or electrochemical corrosion? As the name wet means the corrosion takes place in presence of water or aqueous medium. Why electrochemical corrosion? Because a formation of an electrochemical cell over the metal, and that causes corrosion. So, corrosion of a metal in aqueous or water environment is called as wet corrosion. See here, when a metal comes in contact with aqueous medium, corrosion takes place. That's why it's so named as wet corrosion. Another example here. Wet corrosion takes place when a metal is in contact with a conducting liquid. The entire liquid is a conducting liquid. This is a single metallic rod made from iron. Now, when it comes in contact with the conducting liquid, one part of the metal acts as anode, other part acts as a cathode. What is anode? What happens here? At a anode, oxidation takes place, and at a cathode, reduction takes place. What is oxidation? Oxidation means dissolution of the metal at anode. Dissolution means the metal goes into the electrolyte as ion. That means there is a loss of a metal or material here. That is nothing but a corrosion. Example is rusting of iron in moist air. So the rusting of iron is nothing but example of wet corrosion. What is the mechanism here? Let us understand. The entire gray color is nothing but the iron metal. Over its surface, this light green color is nothing but conducting liquid, that is water. So now a part of the small part basically acts as anode, and the rest of the surface of a metal acts as cathode. As I mentioned, at anode oxidation takes place. Oxidation means dissolution of the metal. Now here iron undergoes dissolution and give rise to ferrous ion, that is Fe2+. Right here you can see here iron goes to Fe2+, and that is dissolution with liberation of electron. Now these liberated electron move to the cathode on both sides. Once the electron reach here, then it react with the oxygen and water, give rise to hydroxyl ion. So at cathode hydroxyl ion and at anode ferrous ion both react and give rise to ferrous hydroxide. Again it react with the oxygen to give rise to hydrated ferric oxide, which is nothing but your rust over the metal. The red is appearance is rust. Wet corrosion also takes place when two dissimilar metals are dipped in a solution. What does it mean? That means when two different metals they come in contact with a conducting liquid, wet corrosion takes place. Example: aluminium, copper. Over its surface, electrolyte is there. Now aluminum undergoes corrosion. Look into here, it acts as an anode, it acts as a cathode. As I mentioned, anode oxidation takes place, means dissolution of the metal. That's why corrosion takes place here. And why it happens here? Aluminum is more reactive than copper. Another example here, steel and copper. See, steel undergoes corrosion here. It undergoes dissolution into iron, ferrous iron. That's why two dissimilar metals come in contact with the conducting liquid. This entire is nothing but the liquid. Then one metal undergoes corrosion. Here also see two different metals. This is one, this is one. At the joint place, electrolyte will be there. Water vapor will be available. That's why water vapor acts as electrolyte. One of the metal undergoes a corrosion. Basically, the metal which is more reactive, that undergoes a corrosion. Now let us discuss corrosion prevention. One method is the coating method. So coating over the metal surface acts as a protection barrier. Coating over the metal surface prevent the exposure of the metal to its surrounding, that is nothing but a corrosion environment, and thus metal is prevented from corrosion. So the principle behind coating is, once the metal to be protected is coated by a metal, then the coating metal act as a, or coating any paint also act as a protection barrier between the corrosion medium and the metal, and the pure metal does not expose to the corrosion medium, hence it is protected. Some examples of a corrosion control by coating. These are some of the examples. Eiffel Tower, that is made from iron, that is a rusted one. Now this is the color. So this is what coated by some paint or by metallic coating. These are some other examples. This is also coated by paint. This is coated by some marine system. This is car. This is the coated one. This is not coated one. These are some examples of a corrosion control in our transport system, like a railway system. So the surface is coated by some coat. It could be paint. Also some metallic coating is possible. Now corrosion control by metallic coating. Basically in our day-to-day life we come across these two examples: galvanization, coating of iron surface by zinc metal. This is one example. The surface is coated by zinc. Tinning, coating of iron surface by tin metal. This surface is tin metal, but the inner metal is iron metal. Now these are the two examples of metallic coating. One metal to be protected is coated by other metal. Now what is the coating metal? Let us have a look into this reactivity series of the metal. A part of the series it is shown here. So here reactivity increases in this way. That means magnesium is the highest reactive among these metals and tin is the least reactive. That means tin does not react so fastly. Magnesium react very fastly, highly reactive. If you look into this, let us position of iron. If you want to protect iron, if it is coated by zinc, then zinc is exposed to the atmosphere, and if fatal corrosion takes place at zinc. Why? Because zinc is more reactive than iron. Similarly, when iron and magnesium, then magnesium undergoes corrosion because it is highly reactive and iron is protected. Let us go to the next slide. This is corrosion control metallic coating by galvanization, coating of iron surface by zinc. This is the molten zinc in the hot condition. Now the iron structure, this is to be protected, is dipped inside the molten zinc and it is taken out. When it is taken out, the entire surface of this structure is coated by zinc. Hence, the base metal or the base structure is protected. Another method is by cathodic protection. What is cathodic protection? It is a technique to prevent corrosion of a metal by making the metal to act as a cathode of an electrochemical cell. As I mentioned before, corrosion takes place at anode, not at a cathode. That's why the metal to be protected, if it acts as a cathode in the electrochemical cell, then it is protected. That's why it is called as or so named as cathodic protection. So here it is two types. One is sacrificial anodic protection, another is impressed current cathodic protection. Let us have a look into this. What are those? So cathodic protection, one is sacrificial anodic protection. What is this sacrificial anodic protection and why it is so named? Let us this metal to be protected. As the name, these are cathodic protection. So the metal to be protected act as a cathode. That's why it is connected to other metal which is more reactive than this metal. Then this metal means the metal to be protected. That's why this metal undergoes corrosion because this is more reactive as compared to the base metal which need to be protected. That's why the corrosion takes place at this which act as anode. As a result, it undergoes corrosion. That's why this metal is protected by the sacrifice of this anodic material. That's why sacrificial anodic protection. That means the metal to be protected is made by the sacrifice of the anodic material. That's why the name sacrificial anodic protection. Example here, iron coated with zinc. Now if at all corrosion takes place at zinc, not on the iron. Why? Zinc is more reactive than the iron. Example of application of a sacrificial anodic protection. Now some metallic rods under the water need to be protected. So at the base of this metal, a more reactive metal is connected to that. So this metal acts as a anode and a corrosion takes place here. Hence this metal is protected. Similarly here also, this metallic rods is protected by fitting some blocks of the anodic material. These are nothing but sacrificial anodic blocks. If a corrosion takes place at these blocks. Hence metal is protected. This is another example of sacrificial anodic protection towards a protection of a hull of the ship. Now how it is protected? You can see here small blocks are there. These are nothing but act as a sacrificial anode, right? So if a corrosion takes place at these blocks and the entire hull structure is protected in the ship. So another method of protection is cathodic protection, that is impressed current system. What is impressed current cathodic system? Here in this system, impressed current is supplied from an external source so that the metal to be protected is forced to behave as a cathode. Once more I repeat. Now in this system, impressed current is applied from an external source so that the metal to be protected behave as a cathode. Hence it is protected. As I mentioned before, corrosion takes place at anode. Have a look into this, a comparative study. Here sacrificial anodic protection, this impressed current cathodic protection. In the sacrificial, what I told, one metal sacrifice to protect the other. So here if you want to protect this metal, it is connected to a more highly reactive metal. That's why this undergoes corrosion and electron flow from here because oxidation takes place here. Wherever oxidation takes place, electron released, electron move from here to the cathode. It is protected. Impressed current system, if this metal to be protected, that behave as a cathode and it is connected to another anode which is a more noble metal or insoluble metal, and the impressed current is supplied from an external source and that acts as electron source. That's why the electron moves from this anode to the cathode and it is being protected. One example of a impressed current cathodic protection. Now the protection of a ship also. Now if the ship needed to be protected, it is connected to another metal, that is anode, maybe a noble metal or an insoluble electrode, and it is connected to an external source, where from impressed current can be supplied. Hence, as it acts as a cathode, the entire chip is protected. So these are some of the references. So this is all about corrosion and its control method. I hope everyone will enjoy this video.